Welcome to the stage, please, Timber Creek High School students.
Just like fire, burning up the way, rocking like the world up for just one day. Watch this madness, colorful charade. No one can be just like me anyway. Just like fire.
Hello everyone, my name is June. This is Samantha, Dominic, Daniel, and we are all students from Timber Creek High School located here in Orlando. So as locals, we give you all a warm welcome into our sunny state of Florida. Thanks to the generous support from our principal, Dr. Paduano, and our superintendent, Barbara Jenkins, our school offers 2 Project Lead the Way programs, PLTW Biomedical Science and PLTW Engineering. Samantha is going to talk more about PLTW Engineering.
Good morning. My name is Samantha Ashby, senior at Timber Creek High School. Project Lead the Way has opened a plethora of opportunities for us to learn and excel in STEM. Before Project Lead the Way, I didn't know what I wanted to do with my life. I was stuck between a professional dancer and a teacher, although one of those was more probable than the other. However, once I took my first Project Lead the Way class in 7th grade, I decided that I didn't only want to major in STEM, but I wanted to do so as a mechanical engineer. Project Lead the Way gave me the basic fundamental skills that I hopefully want to use in my future to be able to achieve such success. One of the many opportunities that Project Lead the Way has opened for me was joining our team's robotics team, being ranked 59-56. On this team, I was able to take the basic fundamental skills I learned from Project Lead the Way classes, and I was able to implement them in a competitive-based environment. From this team, I not only was able to use previous skills, but I was able to learn new techniques through being able to limit friction while increasing torque, but also learning that success is not always greater than failure. Throughout the year, we faced several challenges. However, we were able to learn from these challenges to improve our designs and our documentary procedures. This led us to winning the Design Award at several regional competitions, and then again the Design Awards at states, qualifying us for VEX Worlds. At VEX Worlds, I had an amazing experience. However, the only thing that made me sad was the lack of female representation among the crowd. So when we got back to our school, me and my fellow captain decided that we wanted to bring more girls in our school into the robotics team in STEM, so they could see what we truly enjoyed. From this, we have tried to inspire other girls to want to pursue STEM and love it just as we do. From this, they have not only learned about doing things such as geared trains and how to properly gear and grease motors, but we have also learned that the expression that people say, that those that can't do teach, because to be able to teach them these skills, you have to be proficient in it yourselves. So I just want to say thank you to all of the teachers that helped guide us into this path. And we want to thank Project Lead the Way for giving me the stepping stones to help go through this path. In the future, I hope to continue on this to find eventual success.
Hello, my name is Dominic Smith. I'm a senior at Timber Creek High School. I've been taking Project Lead the Way classes since 7th grade, and I'm currently taking them now. The soft skills and critical thinking that Project Lead the Way has taught me have become invaluable to me currently, because it is these exact skills that allowed me to gain an internship at the University of Central Florida's Advanced Material Processing and Characterization Laboratory. During my time there, I worked on gas atomization, sample preparation and testing, and scanning electron microscopy with quantitative analysis. But while I was there, my main focus was on gas atomization. Gas atomization is the process of taking a metallic alloy and melting it around 900 degrees Celsius, and then pouring it into a highly pressurized stream of gas. Once this is done, it produces a fine metallic powder that can be used as the main material in a form of additive manufacturing called metallic 3D printing. After each gas atomization run, we would clean the machine of all its powder and take it and sort it by grain size. Once we do that, we would mix it with a 2-part resin that, once hardened and polished, could be put under a scanning electron microscope to determine the particle size and the consistency of the gas atomizer. This opportunity was only given to me because of how I was taught to think and how I learned through Project Lead the Way. Now,
Hi, I'm June. Project Lead the Way first sparked my interest in forensic science when I took biomedical principles of biomedical science, and we had to determine the cause of death of Ana Garcia. And that really sparked my interest because when we were walking the crime scene, when we were analyzing blood samples, I found it really fascinating. And at the same time, a health-oriented competition team started at my school called HOSA, and one of the competition events was forensic medicine. Guess what I competed in? So last year, I advanced to HOSA Internationals, and I was one of the competition finalists in forensic medicine. I attribute a lot of my success to Project Lead the Way because Project Lead the Way really gave me the base understanding and the skills that I was able to carry over into HOSA and find success. Project Lead the Way has also given me experience applicable in areas outside of school. Over the summer, I participated in a program that allowed me to conduct research at UCF, University of Central Florida, and there I worked with aptamers. So what aptamers are they are DNA molecules, and they act similar to antibodies. However, aptamers can be seen better as antibodies and a possible substitute for them in the future because they are more cost efficient to mass produce, and they could replace them in therapeutics or diagnostic tests. So what I worked with are two strands of aptamers, DAB1 and DAB2. Their names don't come with a dance move, though that would be cool. It stands for dipoxyl aptamer binary, and it binds to the dimolecule dipoxyl. So our goal was to see if, by incorporating proteins into the aptamer structure, if we could improve the ability of the aptamer to bind to those dimolecules. And while I was doing research, I found that a lot of the skills I was using in the lab had been transferred from what I had learned in my biomedical class, medical interventions. Because when I was doing the lab, I found that micropipetting, a basic skill that I learned, was one of the most essential skills I was using in the lab. Because what I was doing is I was taking tiny volumes, microliters of solution, and mixing them in other solutions. And if you don't draw enough solution, then the concentration would be off, and it could mess up the lab results, and then I have to start all over again. And so thank you so much to Project Lead the Way for giving me the support that really allowed me to find confidence and success in what I'm passionate about.
Good morning, everyone. I'm Daniel Wu, and that's me on a bad hair day. I've been roped into doing biomed for the last 4 years, and I'll admit, at first I had some reservations, but I can say now, without a doubt, that taking biomed is one of the best decisions I've ever made in high school. You see, Project Lead the Way is more than just a class. It is a curriculum. They teach you lab skills that you won't find in any other class, how to plate bacteria, how to do ELISA testing or blood typing. But they also teach you softer skills, how to present in front of an audience, how to make a research paper, make a research poster, and how to sell yourself in interviews and internships. And it's this latter skill that I really enjoyed. In fact, I got my foot in the door in research through Project Lead the Way. In sophomore year, our teacher, Ms. Stevens, encouraged me to seek out research opportunities. I sent out a bevy of emails hoping to get a reply, and I landed an internship at Moffitt Cancer Center in University of South Florida. There, I worked with Dr. Robert Gatenby doing computational modeling of adaptive therapy on late-stage metastatic castration-resistant prostate cancer. The ideology behind adaptive therapy really fascinated me. We took rules of ecology, the same rules that govern the interactions of wolves and rabbits, and we applied them to the tumoral microenvironment, to the interactions between immune cells and cancer cells. And when you start seeing cancer cells not as an illness, but as just another competing species in the tumoral microenvironment, your perspective radically changes. This mind frame shift caused me to see cancer not as a disease to be eradicated immediately, but as something to be controlled. We must aim to treat to control rather than treat to kill. And this concept fascinated me. I was enraptured for far longer than my summer internship would allow me to be. And so when I went back to my school, I spent the entire year in MI doing independent research into cross-applications from ecology to oncology, evolutionary biology. I spent every day reading deeper into the literature and trying to find another way in which I could be involved in the cutting edge of this field. All that work paid off. Last summer, I had an internship in Washington, D.C. at the National Cancer Institute with the Department of Cancer Prevention. There, I worked with Dr. John Pepper in doing computational modeling of the effects of resource oversupply on carcinogenesis. We started from risk factors such as obesity and inflammation, which we know are associated with cancer, but we aren't sure how. There are molecular explanations, of course, but my model did simulations to see how this resource oversupply evolutionarily allowed the creation of cancerous phenotypes. I finished my research and presented it at several conferences, which I thought was going to be scary, but then I realized it was just like presenting to my class in Project Lead the Way Biomed. Project Lead the Way has also given me more skills that have helped me more directly. Last summer, I was one of 20 to be picked as a national finalist in USA Biology Olympiad. Out of an initial pool of 10,000, us finalists were invited to 2 grueling weeks in Washington, D.C., during which we spent up to 14 hours each day in lab and lecture. We did things that were oddly familiar to me: culturing bacteria, doing endospore staining, doing gram staining. And in each of these labs, I heard the voice of Miss Stevens in my head going, "Don't you dare wear open-toed shoes in the lab. Don't you dare plate that bacterial plate right side up. Don't you dare put that hot inoculating loop in the vial of alcohol." And it is with these tips in the back of my mind that I ended up as sixth in the nation. So, to wrap things up, to all of you educators, teachers, and administrators out there in the audience, I want to give you my thanks, because every single day, you open up new opportunities for us that we would have never before considered. Every single lesson, you plant seeds in us that we hope will sprout. Thank you.